Hello everybody, welcome to the first video of what I hope will be a series in which you and I will be learning how to create procedurally generated textures in the Python variant of processing. Today this video will include just the very basics of how to set up a quote-unquote hello world program and then how to apply some effect to every pixel on the canvas. And so without further ado, let's get right into it. I'm assuming that you know basic Python, but I will be introducing new functions that processing brings to the table as we go along. So to start out, every processing program has this basic stuff here. You define the setup function and the draw function. Those are sort of the two parts of your program. You define in the setup function the size of your canvas and the mode. I'm going to be in P2D for my mode, which is the 2D version. There's also P3D, which would be the 3D version, but we're making 2D textures, so we'll be in 2D. Here we declare any global variables that need to be accessed later on in the draw function. And here's where you do things like initialize your variables. So we'll say here t equals 0. In this program we're going to be using t for time. And if we need any other global variables, we'll separate them with a comma. So we might say, you know, geese, if we need a list that has geese in it, I guess. In any case, let me fix that. There we go. In any case, so the setup function is run one time at the beginning of your program, and then the draw function is called, I believe, 30 times a second, and so it is essentially your frames. So let's start out here in our draw function, or our setup function. Let's just run. Let's just hit run. If I hit Control R, it will run the code. And if we look here, here we go. We've got a canvas that is 600 by 600 pixels as defined in the size function up here. And right now it's like entirely blank. So let's try giving it a color. So I'm going to say background 0. Now, processing is very nice in that it will accept RGB, so 0, 0, 0 would be black, or if it's just grayscale, it'll take one argument. So I'm gonna leave it at black for now. In fact, I'm just gonna comment it out because we don't need that right now. Next, we're going to go down here and get started on what we call a nested while loop. So to make one, well, to make a normal while loop, you might say something like this: while x is less than width, x plus equals 1. So this here declares a variable and sets it to 0. And then loops over whatever code we put in right here, where I put this comment, over and over and over again. Each time x will increase by 1, and when x is less, or once x becomes greater than the width of the canvas, which is 600 as we defined earlier, it will stop the loop. So then the clever part, if we put another while loop inside of it, we'll call this one y. While y is less than height, y plus equals 1. Code. So if we put our code there now, it'll apply. This basically loops through 360,000 times. This code right here will be run once for every single pixel. So if I said stroke y, and then I said point x comma y, well, stroke sets the color of this point. It's going to fill in 1 pixel on the screen at these coordinates, x comma y. Remember, x and y are our variables up here that are increasing. And then it'll set the stroke to be whatever that is. Stroke is, 0 to 255 color base. So if we hit run, there you go. You'll notice it stops a little less than halfway down, and that's because our canvas is 600 pixels, but we're just plugging y straight in there, so it only goes up to 255, and then after that it stops, because you can't put in a number higher than 255 in for stroke. So the next important function after stroke and point would be the map function. C equals map, and we are going to take y, which is between 0 and height, which is 600, and we're going to tell it to map it to basically stretch it out to be between 0 and 255. So basically it's going to smoothly scale it to be between 0 and 255. And what that means is if we run it now, it takes up the whole screen, because now it's worked out the math for how to stretch it and keep it looking smooth. So that's handy. Let's say we wanted to do something different. What if we wanted to be a bit more random? So what if we did C, which stands for color? It's just, the variable name I chose. Generally, it's a good idea to pick more useful variable names, but color is already taken, apparently. C equals random. Random between 0 and 255. Processing doesn't require me to say 0, comma, it just assumes the 0 if you don't include it. So this will give me a random value between 0 and 255 for each and every pixel. So if we give it a moment, oh, there you go. It kind of looks a little stretched. Did we miss something? I think we're good. No, it looks normal. It must just be my screen or my eyes or something like that. In any case, so that sort of generates TV static, and you'll notice it was actually changing, and that's the frame rate. The frame rate would normally be a lot higher, but it takes it a very long time to render out each frame, because it needs to do 360,000 random numbers. It has to generate them and then draw them on the screen, and so that takes it a while. So if we made it a much smaller canvas, so let's say 100 by 100, well, now it's a lot faster, because it doesn't have to do nearly as many calculations. Alright, so let's put it back to 600 by 600. If you wanted a static image, you could come down here, copy all this, and put it up here in setup, by the way, in case that's useful to you. A lot less laggy on your computer. Anyway, we'll take this and move it back down here. We can also draw other patterns. We can draw, for instance, stripes if we add perhaps an if statement. We say if x mod 2 equals 0. One moment. We say else stroke 255, then anytime x is even, or at least that anytime x is evenly divisible by 2, which is anytime it's even, stroke 0, and otherwise stroke 255. So if we run that... Okay. So So I was wrong earlier when I said to use P2D. Don't use P2D for this. Apparently P2D has some minor difference. If you just leave out that argument entirely, it'll solve the problem completely. Now I don't know about your screen. When I look at it on my main monitor, it's a bunch of incredibly fine vertical stripes. When I look at it through OBS, though, it gives me some rather thick stripes, and I believe that's because OBS is like resizing what I'm recording a little bit. And I really can't tell you what it's going to look like on YouTube, so I wish you good luck on that front. We can do stripes. What if we did Y, when Y is divisible by 2? Well, that would give us stripes in the other direction, the horizontal direction. What if we did and x mod 2 equals 0? Now it's a really fine grid. What if we did OR? Well, that loads. I'm going to point out that you can put in anything. You can put in any kind of if statement that you want and get all kinds of patterns. And there's an entire field of computer science dedicated to generating interesting patterns based on certain rules. I recommend you look into what's his name? Conway's Game of Life and Wolfram. Wolfram Alpha, I believe, is the name. I'll have to double check that. Somebody correct me in the comments if I'm wrong. But those are both rule-based pattern sort of things. In any case, next episode we'll be getting into perlin noise to create something a bit more useful. We're going to create cloudy textures, and we may even get into making that perlin noise change over time and make it like, you know, shift around and swirl and all kinds of things. Then the series will go into warping and domain warping and other kinds of noise and mixing noise and all sorts of things. So in any case, thank you for watching. If you liked the video, please subscribe, and that'll be all for today. See you in the next video.